The North Connects project is well underway, with tunnel excavation nearing completion, and we'll begin transitioning into the disciplines of civil fit-out and pavements. The twin 9-kilometer tunnel consists of a no-fines drainage layer, sealed with a layer of asphalt and then a final CRTP base layer. The base layer is to be constructed in 3 runs: the slow lane, the shoulder, then the fast lane. The challenge was to find an optimal solution to deliver concrete to the paver, and I was like, a challenge. I'm always up for a challenge. First things first, set out the rules of the game. What are our restrictions? Which options are available to us? Then map it out. Present the problem on a drawing and see what your limitations are. Next, we tested out our assumptions, put the drawing to good use, and test this out in the field. A trial was held in the quarry, and we simulated what would be our restrictions in the tunnel, coupled with our ramp solution. We simulated various turning circles to determine which would be optimal to use in the tunnel, keeping in mind a few key factors: patches within the tunnel wall, turning circles and required swept paths, total turnaround time, and ease of maneuver. The trial run was successful and confirmed that the physical limitations of the tippers matched those of what we assumed on a piece of paper. Now back to the office. The next step is now to fabricate these ramps, get a prototype made and delivered, and run another simulation trial with real steel ramps. These ramps will allow us to reduce our waiting time for each truck, improve cycle times, whilst providing a safe and optimal solution for delivering concrete to the paver.